Assalamu alaikum. I am Miraj Hussain Alif, and this is my OBE assignment in DLC Digital Logic and Circuit. My ID is 2350991, and the value of d is equal to 0 is replaced by a plus b plus h, so it will be 2 plus 3 plus 1 is equal to 6. So in my first task, I design the overall block diagram and system flow of an automated parking control system. A keypad is used to enter the maximum parking capacity, which is stored in a registered entry, and exit sensor detectors cars entering and leaving the parking area. Also, these signal are connected to an up-down counter built using flip-flops. The counter output is compared with the maximum capacity using a comparator. Based on this comparison, the system decided whether the parking is full or space available and controls the display of accordingly. So in my first question, there is the maximum car count b plus f plus h. So that will is equal to 3 plus 9 plus 1 is equal to 30. So I designed the overall block diagram. If that is if the enters and exit, uh, it will get in counter sensor and it will be decoder. If for maximum, my maximum car space is 13, so if it is less than 13, so that is stable space available, display space available. Or if the 13 is equal or more, then it is most stable full, but it will be display full. That is my flow diagram. uh, Start states, counter setter, check entrance, then that is check exit, car count, display, and that will be repeat again and again. So this is my counter diagram. My capacity is 13, so we need to use 4-bit counter, because 4-bit is the maximum count to 0 to 15. So we have let 1 is equal to up entry sensor, that is counter reset, and 0 is down exit sensor of counter load, and that is the counters. So maximum car count is 13, so 13 bit number is 1101, then it is replaced again 0. The 0 number is binary number is 0001. So I use jk flip flop transition table. So first, uh, I use 4-bit up counter and also count the J0, K0, Z1, K1, Z2, K2, and Z3, and also K3. Then I also use the K map of J0, J0, Q2, Q3, J1 is equal to Q4, and J3 is equal to 1. And also I uh, write the K0 K maps, K1, K2. K2 is also look like as J3. So in J3, uh, I send 4-bit up counter. I design 4 up counter architecture design, that is clock pass, and there is a 4-bit. So counter is Q1, Q2, Q3, and Q4. And also I write a 4-bit down counter, that is my 4-bit down counter, and output will be Z0, K0, Z1, K1, Z2, K2, and Z3 and K3. And also I write the K map of J0, Z1, and design the 4-bit down counter clock pulse. So in The question number two, I designed the display control circuit using two triple five timers. One timer is used to continuously display the world full when the parking is completely occupied the occupied, and the second timer operates in the stable mode. First is monostable mode. If the space is available, we can monostable. For the 7 segment display, we use an stable, and that is our comparator. We use two triple five timer. The duty cycle frequency of the capacitor values are selected according to the given parameters. So maximum car space is 13, and D will is 6, and duty cycle is equal to D percent 100 minus P. So D is equal to P is equal to 56, and in the question there is also a formula A plus B plus D plus E plus G into 2, so that will be count 56. Also I count a T is equal to 83.4 millisecond. So we know the duty cycle formula is TH divided by TH plus L, and also TH plus TL is equal to time. So we count a TH and TL. So which capacitor is for best? 50 U Faraday, 250 U Faraday, or 470 U Faraday? So in 50 U Faraday there is low, there is high ohm, there is high ohm, and also for 70 U Faraday there is also low ohm. So 200 in 250 U Faraday that will be okay. So from the given capacitor we are going to use the 250 U Faraday. In my question 3, a for in my question 3, I prepared a FSM design that generates two outputs A and B, and output A remains the active for ms and output B for ms with a 1 millisecond clock period is 1. So in second question, uh, we calculate the value of THTL. So is C50 to 250 capacitor. So it is high time TH is greater than 4 and low is greater than 4. So we are using two state for FSM design such as S0 and S1. So S0 is a 4 clock cycle, and S1 state for the 4 clock cycle mode. There will be a toggle in every 4 cycle. There is a state table, and there is a our state diagram. So then the FSM include a state diagram, also a state table, and the last the FSM includes the Verilog SDL code, that is Verial SDL code. In question number 4, there are many drawback or limitations for the question 1 and 2. What are the drawbacks and limitations for question 1 or 2? That I write in the question number 4. As from the design and ID limit, maximum ID card is 13 cards, so it means it max limit is 13, so 4 bit counter is used. And then design can be adjusted dynamically because the duty cycle and frequency at the blinking display are fixed register and capacitor values in the triple five timer circuit. A single entry and exit is effective for small gates but won't function well with the several gates. So basic screen mean it doesn't indicate the number of space available. It only display full or space available. For making a higher number of cars, what we do? We using a microcontroller for FPGA makes the system smarter and easier to expand like zone control and space counting. Also, we use install spot sensor for more precise tracking and improved driver resistance. Install sensor in every area. Improved display, we used LED or LCD panels to display the precise space numbers or directions, and also we link with the online, so that will be help the drivers if the space available or not in via online. So this is my answer of four task digital parking control system.